This is section 6.2, volumes. So it's very similar to the previous section. This time this is a solid. So if you look at the cross section is going to have a thickness, which would be our delta x, and then it's going to have a surface area. That's going to be the area of the cross section. So here it is, the area of the cross section times the thickness is the volume, and this Riemann sum can be written as an integral. So let's look at the first example. Find the volume of the solid obtained by rotating the region bounded by the given curves in the specified line. So there's two types that we're going to focus on, a disk and a washer. This first one is a disk, as you will see. So let's sketch the graph. So that's going to look like this. This graph is going to look something like this, square root function. And it's going to go from 0 to 5. Let's see, y equals 0 is going to be this horizontal line right through the x-axis, and then x equals 5 will be this line, this vertical line. Whoops, let's try that again. That vertical line. And so if you rotate that over the x-axis, it's going to create a solid. And so we can imagine that it would look something like this. And then the cross-section would be a disk. It's going to have a thickness. And so the radius is just this length is the radius. And as you can see, the radius is simply this function, which is a square root function. So because the cross-section is a circle, we can use pi r squared as the area. So the area of the cross section is pi r squared. And the radius is this height, which is simply this function. So the integral is going to, the volume is going to be written as the integral from 1 to 5. Pi r squared. So pi, because pi is a constant, I'm going to take it to the outside of the integral, which you're allowed to do. And then the radius squared, we said that the radius is square root of x minus 1 to the second power with respect to x. And so that's going to cancel that out. And now we're going to have pi from 1 to 5, x minus 1 dx. Integrating that will give us 1/2 x minus x times pi, and that is going to be from 1 to 5. So plugging in 5 is going to give us 30, what is that? Actually, I'm missing a square here. So that's going to be 25 over 2 minus 5 minus 1/2 minus 1. All right, so this is going to be negative 1/2, but then the negative makes that positive 1/2, so this is just going to become plus 1/2. All right, and if you add 1/2 to 25 over 2, that's 26 over 2, which is 13. So it's 13 minus 5 times pi, which is 8 pi. All right, so that was an example of a disk for the cross section. Now let's take a look at a washer. So a washer is going to be very similar, except there's going to be a hole in the middle. So it's going to be the outer circle minus the inner circle. So here it is. Find the volume of the solid obtained by rotating the region bounded by the given curves in the specified line. Usually you'll have a washer when you're not rotating about the x or the y-axis, but rather a different line, such as this one. So let's look at that. All right, so y equals x squared is just going to be a parabola with vertex at the origin. And then x equals y squared is a parabola, but it's a sideways parabola that's going to look something like that. It's also has a vertex at the origin. And so we're going to look at the point of intersection. If you substitute x squared into y here, that's going to be x equals x to the 4th, which means x4 minus x equals 0, which means x cubed minus 1 equals 0. But just by looking at this, you know that 0 is a point of intersection, which is clear from setting the equations equal to each other. And you can see that this other point here is most likely 1, which it is. 1 also would be a solution to that equation. And so now we know that this is 0, this is 1. And if you plug 1 back into x, you're going to get 1 for y, which tells you that this is also 1. And that's the line that we're rotating over. So if you imagine this little piece getting rotated over this horizontal line, it's going to create another little section above. And then if you rotate that, the cross section is going to be this washer with a hole in it. There's a hole. So it's kind of hard to see there, but you have this outer circle and then you have the little circle. So you need to subtract the inner circle from the outer circle. So that's why the area of the cross section would look like this. It's going to be pi big R squared minus pi little r squared. The difficult part, at least for me, I think, is figuring out what the radius is, because the radius is not just the top function or the bottom function here. Because we're centered at somewhere other than the x-axis, that means you have to consider this line of rotation, or the axis of rotation. So what we need to do is we start from 1, and then we're going to subtract this little piece, which is the bottom function. This bottom function is x squared. So there's your radius. It's 1 minus this small little piece. So the radius, which is big R, is going to be 1 minus x squared. Now little r is going to be this distance right here. I'm sorry, this distance right here, that's little r. So it's going to be 1 minus the top function. This top function, which is this one here. But you need to solve for y, because we're integrating with respect to y, with x, integrating with respect to x. So if you solve for y here, you're going to get y equals square root of x, plus minus, but we're only considering this one. We're not considering this one. So this is so your small radius is going to be 1 minus radical x, because it's this distance. As you can see, this is 1 minus that, which is radical x. All right, and now for our integral, our volume is going to be pi. I'm going to move the constant out to the front. Big R squared minus little r squared, all with respect to x. And our limits of integration would be from 0 to 1. All right, after you do a little algebra here, you're going to get 1 minus 2x squared plus x to the 4th minus 1 minus 2 radical x plus x. All right, and then that is going to simplify. Let's see, if we simplify, the ones will cancel, and then we'll have x to the 4th minus 2x squared plus x minus 2. I'm going to write that square root as to the 1/2 power. Actually, that becomes positive if you distribute the negative, and that becomes minus. All right, and now we can integrate. All right, so the antiderivative would be 1/5 x to the 5th, 2/3 x to the 3rd, 1/2 x squared. This is going to be 4/3 x to the 3/2. 0 to 1. Luckily for us, we don't need to plug in the bottom limit, because it's going to cancel everything out. So we only have to plug in the 1, which makes this arithmetic a little easier. It's simply going to be 1/5 minus 2/3 minus 1/2 plus 4/3. And with our common denominator of 30, this should be that's going to be 6 take away 20 take away 15 plus 40, which is going to be 11/30 times pi. The pi is here, And that is our final answer.